Hi everybody, so this is week 3. We are going to be looking at converting our algorithms to actual Python code this week. So last week we talked about the 4 kind of calculations within our algorithms. We had input, output, compute, and save. Those are kind of the 4 keywords we were building on. So this week we're going to look at converting those keywords into actual Python code that we can then write, test out here. So I pulled up my terminal here. If you're on Windows, it's just pull up a command prompt, and then I'm just going to run a Python 3. For me, that's going to load Python 3.3.3. For you, you might just have to call Python, and it will do it. It's probably not named Python 3. Mine is simply because my system has Python 2.7.5 also installed. So I have both of them installed. We're using Python 3 for this class, but I still need Python 2 on my system for some stuff to work. So just going to look here at this is an interactive shell. It's called idle, and it basically allows us to write code, and it will kind of do it as we go along here. So I don't need to save a file and then run that file, kind of, we did last week with the Hello World. That's how you'll want to work on your assignments. But this is just an interactive shell if you want to test some stuff out, or want to see how certain things work, or anything like that. So you can't actually save this code from here, so that's why you won't want to write it. But just to kind of look at for some examples, we'll check this out. So I'm going to begin just by going through here what I just did there. I just ran this function called print, and you can basically see that it does the output part of our algorithm commands. So we'll look and see kind of later in the semester there's some other ways to format output as opposed to just saying print and then printing it out, as we get some more variables and want to do some formatting on them and things like that. But for now, simply just use a print, open parenthesis, some stuff, whatever you want in here. It should be a string, so this is a string, and we'll talk a little bit more about that, and then close the parenthesis, and it will print that out. So when I say a string, what I mean is that we're talking about letters, or really anything enclosed in quotations. That's the string 100, as opposed to a data type for integer or float or something like that. We'll see that again in a second here, but I'm not really going to go that deep into data types this week. We'll learn a little more about it kind of as things go on here in this semester. So just for now, know that when you print things, you're printing strings. So that's the output. So input, if you want to take in some data from a user, it's pretty simple. Just call the input function in Python. We don't have to import anything. If any of you guys have like a C background or Java or anything, it's quite a long process to be able to ask the user for data. But in Python, pretty simple. Just call this input function. It allows us to type stuff in here. 100. Okay, I got 100. Do it again. I type in some characters, right? ASDF. Okay, it outputs ASDF immediately, just to show you that that's what you input. So the way that this function works is you can put a string prompt, and it will then use that prompt when it calls. So if I wanted, for example, to say, give me a number between 1 and 10, then when this code is ran, it's going to prompt that up. There it is. And then I could say, 5. Okay, got 5. So you can type in a string, pass it as an argument to this input function. If those words don't mean much to you right now, don't worry about it. Just know that when you call this, when you write this, you can add some stuff in quotations between the parentheses and it will use that as a prompt when asking for the data. Okay, so shown that we can put in a number. We could also pass me a letter from the alphabet. So A, right? We can say that and it gets it. So one thing you should notice here is that when it gets these things, it's showing you, okay, what you put in here is an A, and it's surrounded with quotes. I didn't put in any quotes. Same with the 5. The 5 has quotes around it, whereas I just put in 5. So what that's signifying is that it's talking about a string. So just remember that anytime that data comes back to you and has quotes around it, it's referencing that data is a string as opposed to some other data type. So we'll see what other data types are available in a second when we get to the idea of saving, but just a second on that one. So the next, so we've covered input, we've covered output, both quite simple. Output, again, is the print command. Input, simply the input command. So let's talk about the compute. This idea of computing. What does that mean? Well, by default, the system can do math, right? I can say 5 plus 5, and it'll tell me it's 10. I can say 2 times 2, it'll tell me it's 4. And it has a couple other operators that it can do, plus, minus, multiply, divide, pretty simple ones. We've also got this idea of, let's see here, 10 divided by 3. So what that means is do integer division, meaning, if I say 10 divided by 3, it's going to give me 3.333, repeating, right, 3 1/3. If I say only give me the integer part of it, as I did here, it just says 3. There's no more data passed. It doesn't care. So if you wanted to just divide the integers without any remainders or any anything like that, let's see what this one gives us. Okay, so that gives us 11 or 3.6. If we do integer division, it gives us 3. So it doesn't even round, it simply just gives us the integer part of the math. So another one I want to show you here is 2 multiplication signs, and that just means raised to the power of. So that's 5 to the second power, 5 squared, it's 25. And then one more kind of an important one. When it comes to computer science, you may have never seen this before, but it's the mod command, modulus, and it basically means give me the remainder from this math problem. So if I say 10 mod 3, right, how many times does 3 go into 10? It goes in 3 times with a remainder of 1. So if I do it with 11, it's going to be 3 times with a remainder of 2. So the answer is 2. So we'll see some things a little later on where this becomes very important. Whereas in your daily math, you don't normally care too much about remainders, but we will see some problems that require that. So this is kind of some simple computing. In the same vein here, talking about math, you can use parentheses. So 5 raised to the second power times by 2. Could get the same thing because order of operations here is the same on that. Let's say we do something like that. It's 5 to the 4th power. So parentheses, in the same way that they work in math, work here. So just so you know that. Okay, so another thing that I want to talk about is on page 22 in your book, and it's keywords. And there's just a bunch of kind of keywords within the language that do, you know, certain things. We're talking about like this print, right? Okay, so print is kind of a keyword. You don't want to really use it for anything else. Try, die, exit, right? These are kind of all like keywords that they kind of have their own meanings. You don't want to really use them for anything, and that's important as we get to this last step here. So we've seen input, we've seen output, we've seen compute, and this last part here is the save. This idea of saving things as variables, and so the way that you save something is with the equals, the assignment operator. So if I wanted to have some variable a, let's say, and I wanted it to be equal to 5, okay, so I could say a equals 5. That's fine. If I then wanted to recall that, let's print a. A is 5. You'll notice there that 5 is actually an integer, a number. It's not a string. It doesn't look like this, right? Oops. It doesn't look like that. It doesn't have quotes around it. So with that, we can start to do some things, right? So a equals 5 plus 5. Right, let's print a. Okay, we're getting 10. So what if I wanted to print a plus 5? Okay, so now it printed my 10, added 5 more to that, but it didn't actually change my a. My a is still 10. It just added 5 as it printed. So once you start seeing variables is when we can really get into doing some things with data. So just a quick look back here. What if I want to use a variable? A is equal to input, give me a number. Okay, so now it says give me a number, I'm going to give it 7. We haven't used that yet. Okay, so now if I say print A, if I write it properly, my A is now equal to 7. It's equal to whatever the user input, and in this case he inputs 7. The one thing that you will see, however, is that if I say, as I did before, print a plus 5, it says, okay, there's an error, can't convert integer object to string implicitly. So when I told you earlier that whenever you use this input function, right? If I put in 7, it's gonna. This is essentially the same as this. Just calling input, so it's basically the same. And I put in 7, and it shows you that it's actually storing as a string. So what I can do here, if I print my a, it's equal to 7, but it's actually equal not to 7, the number, but to 7, the string. So this is kind of where the data types thing comes into play. So what was happening, getting this error, is it's saying this a is equal to a string of 7, and you're trying to add a number to a string. So it's saying I can't convert an integer, this 5, to a string. So if I instead did something like this, right, I've got the string of 7 in A, and I'm adding another string to it, which is 5. Okay, it prints out 7, 5, as opposed to actually doing the math. It did string addition, whereas, you probably don't want that. You probably want math addition, right? So I'm just going to give you kind of a really quick tutorial on how to kind of fix that type of thing without going too in depth. So there's a thing called typecasting within programming, within computer science, that allows you to change the type of a data type. So in Python it's really easy. We can just say int and then put whatever we want to have changed within parentheses. So if I did this, right, I've got a string of 7, it's in quotes, and I'm casting it to an integer. Okay, so when I cast it, it changed here. So if, for example, we've got our A, and we know that it's it's a string of 7, and I want to change it to an integer, so I could say int of A. Okay, so rather than having quotes around it, it doesn't have that anymore. It's now just this 7. So if I wanted to, print int a plus 5, should get 12 now as opposed to 7 5 or some error. Okay, so we do cast. It changed it. I could do it, permanently. A is equal to itself as an integer, and then print, a plus 5 in this simple manner. We could do it when we input. So if I could remember to type everything. Okay, so it says give me a number. If I say, 3, I say show me A. Okay, you notice that there's not any strings around it. So in one line, we kind of did two things here. We ran this input, and then whatever came back from it immediately got cast to an integer. So in the book, you'll see, you can cast integers back to strings with the str. You can cast them to floats or doubles. I think it's simply float. Can't remember off the top of my head. Let's see. Yeah, so it casts it to a float, which 3.0 versus just the integer value. So you can cast things like that. Okay, so the last thing I want to talk about here is naming these variables. So I've just been using a this entire time. A equals something or other. For now, that's probably fine. We probably have one variable in our code, x. That's what you're used to seeing in math class. Let x equal 10 or whatever the case. But as we get into more complex things, we will be hampered if we name our variables simply with letters, because we will forget what they are. So two things on that. One, you can't name them a keyword. Don't name your variable print, right? You simply can't. It doesn't work. If I now say print, okay. So what happened is I broke my print functionality. I overrode it with this call. So you don't want to do that. You start breaking things if you do that, if the language even allows you to do it. So it's not what you want to do. All right, so I got my print back. So you want to make sure that you name things, but you don't want to name them keywords. You want to name them valid things. So if I'm getting, an integer from a user, what am I doing with that integer? Is it, for example, I think in one of our problems, is it miles per gallon? Is it miles? Is it gallons? If it's miles, then let it be miles. So, something like that. Now, when I go to print that thing out, all right, I know I'm dealing with miles. The code is very readable when you do that. You can look at it later on and know, what variables are what without having to start at the top of the code and read through all of it. So that's kind of all for this week. You need to read pages 10 through 22 in your book. It'll just kind of, give you a little more depth on this stuff, a couple examples, kind of talk a little bit about data types and keywords and variable names and operators and things like that. And then the assignment will be posted. Thanks.